everyone, welcome to section 3.3 where we do polynomial long division. To this point we've talked about zeros, we've talked about factors plenty of times. So what we're going to do in this section is if we have the opportunity to divide by a factor that would help us divide and then factor some more, we would like to take that opportunity, right? So what we're going to do is take some really big polynomials, try and divide them by certain factors, and if we divide them by factors, they might be factorable. So for example, we could potentially go from something that's like x to the fourth that we can't factor, but if we divide by a certain factor and it works, then maybe we have something with x cubed, and then we can then factor from there. So it is a popular tool, it's a very famous tool. There's two ways we're going to do it, so yeah, let's get right into it. So how we're going to do this is a lot like how we did this for numbers. So think about when you were in elementary school and you did something like 830 divided by 5. Well, you would set this up as 830 over 5, and then you would say 5 into 8 one time. You would do 1 times 5, which is 5. 8 minus 5 is 3. Then you would bring down the next number. 5 into 33 6 times. 6 times 5 is 30. Bring down the 3. And then we get 5 into 30 6 times. And that's 0. So we say this is 166. But another way we could say this is that 830 is 5 times 166. So that kind of ideology is going to carry us for these first few examples. So let's do just that with polynomials. Okay, so the first example we're going to do is x cubed plus 2x squared minus 5x minus 6 all over x plus 1. Okay, so how we set this up is a lot like how we set this up for numbers. We would say x cubed plus 2x squared minus 5x minus 6 divided by x plus 1. Okay, but how we do this is a little different. When we do it for numbers, we're used to saying 5 into 8 one time, but it's not that easy because we have an addition here or even a subtraction. So what we're going to do is this. We're going to ask how many times does this first term go into each consecutive, or successive I should say, term. And what I mean by that is how many times does x go into x cubed? What I'm really asking is what is x cubed divided by x? X into x cubed is saying x cubed divided by x, which is x squared. So what we're going to do with x squared is line it up with the other x squared terms, right? We want to make sure we're lined up, just like we're lined up for tens, hundreds, thousands when it comes to dividing numbers. And what we're now going to do is the same step as we did for numbers. When we said 5 into 8 one time, we would then say 1 times 5 is 5. And we're going to do the same thing here. X squared times x plus 1. Okay, x squared times x cubed. X squared times 1, x squared. Okay, and now we subtract. So it's a little different because we're not subtracting just single numbers. This time we're subtracting expressions, and that's a-okay. If we did this correctly, these two things should be the same. This says x cubed minus x cubed. Oh, well, that goes away. That's pretty nice. But then this says 2x squared minus positive x squared. Well, 2x squared minus positive x squared is just x squared, right? 2 apples, you subtract one of those apples, you now have 2 apples. Okay, and then just like we did for numbers, bring down the next term. Okay, and now we rinse and repeat. So now we ask, how many times does x go into x squared? Or in other words, what is x squared divided by x? And that's just x. So now we put x up here, and we again do x times both of these. X times x is x squared. X times 1 is x. But now we got to be a little more careful. Again, if we did this correctly, x squared minus x squared, that's just 0. But here we have negative 5x minus positive 1. You're $5 in debt and you spend one more dollar. You now have negative $6 of debt. Okay, bring down the next term. And now one more time, x into negative 6x. negative 6x divided by x is negative 6. All right, and one more time. Negative 6 times x, negative 6x, negative 6 times 1, negative 6. And in this specific case, this is pretty nice. Negative 6x minus itself goes away. Negative 6 minus itself goes away. We're left with 0. So now, our original question asking what is x cubed plus 2x squared minus 5x minus 6 divided by x plus 1? Well, this equals x squared plus x minus 6. Okay? X cubed plus 2x squared minus 5x minus 6 over x plus 1. Well, what we can do like we did with numbers where we said 830 divided by 5 is 166, we can multiply x plus 1 on both sides. And even better yet, this factors to x plus 3, x minus 2. So what polynomial division did is that if we find a factor that is indeed a factor of our original polynomial, just like 5 is a factor of 830, if we find one of these that works, well, it lowers our degree of our polynomial to a point that we could potentially factor it. So this, before, you would never have been able to factor using regular means, but just like that, with one run of polynomial division, now it is factorable. And that's the idea. Okay, let's keep going. Let's do some more examples. Okay, so next up, we're going to do x to the 4th minus 26x squared plus 25 divided by x minus 5. So what we're going to do here, same thing, let's set it up. X to the 4th minus 26x squared plus 25 over x minus 5. And now what we're going to do is say x into x to the 4th. X to the 4th over x is x cubed. And, well, that's kind of weird because we don't have a spot for x cubed. Well, whatever, let's throw it up here for right now. Now we do x cubed times all this. So x cubed times x is x to the 4th. X cubed times negative 5 is negative 5x cubed. And just like that, all of our terms are out of whack. Notice this is x squared, this is x cubed. We can't subtract like that. So what we're instead going to do is put placeholders in for all of these powers of x that we're missing. So this is a bad setup. And again, if you are missing powers of x, what you instead need to do is this. Okay, x to the 4th, next term is negative 26x squared, but since we're missing an x cubed term, let's put 0x cubed there. Minus 26x squared, we're missing an x term, so let's put 0x there, plus 25. Okay, so same thing, x into x to the 4th, x cubed times x to the 4th, x cubed times negative 5, negative 5x cubed, and now we have less of an issue because we have x cubed terms that line up. However, be very careful here because what we're doing is x to the 4th minus x to the 4th. That's the whole point, it goes away. But here, 0x cubed minus negative 5x cubed. Well, this is plus. So this is positive 5x cubed. So please be very careful when you are subtracting. Don't forget parentheses. If you forget parentheses, you're going to just subtract here, and this will be negative, and then you're going to be all sorts of thrown off. Okay, so please be very careful of that. We continue, minus 26x squared, x into 5x cubed is 5x squared, 5x squared times x, 5x cubed, 5x squared times negative 5, negative 25x squared. Okay, those are the same. But over here, careful, negative 26x squared minus negative 25x squared. Well, negative 26x squared minus negative 25x squared is plus. You're $26 in debt and you're given $25. You are now just a single dollar in debt. And we bring down the next term. Okay, x into negative x squared is negative x, right? Don't forget each of these steps. 5x cubed divided by x. That's how we get the 5x squared. Right here, negative x squared divided by x is how we get negative x. All right, negative x times x, negative x squared. Negative x times negative 5. Ooh, positive 5x. All right, those are the same. 0 minus positive 5 this time. Okay, you have nothing in your bank account and you spend $5. Now, negative 5x again. One more time. X into negative 5x. Negative 5x divided by x is negative 5. Negative 5 times x, negative 5x. Negative 5 times negative 5 is positive 25, and both of these are the same. And we found a factor. So this original polynomial is equal to x minus 5 times all of that. And if you wanted to, this can be factored by grouping, and you can continue to factor this polynomial. So that's a really nice, powerful tool. This could have actually been factored in the beginning if you have a little bit of foresight, but let's assume we don't know how to do that and instead use division. Okay, let's move to something a little different now. So both of these examples worked, but we know in division that that's not always going to be the case. So what happens when something doesn't work? Okay, so in terms of numbers, what if we did 830 divided by 7? Okay, 830 divided by 7 would be 830, 7. 7 goes into 8 one time. 1 times 7 is 7. 8 minus 7 is 1. Bring down 3. 7 into 13 one time. 1 times 7 is 7. Bring down 6, and we get 0. 7 into 60 8 times. 8 times 7 is 56. 4. Well, 7 doesn't go into 4, so what you are used to doing in elementary school is to say 118 remainder 4. Well, here's what 118 remainder 4 actually means. What this means is if you were to divide 830 divided by 7, you would have 118 7s plus 4 of the way to 7. You go around 118 times, and then you get 4 more steps to your next 7. Well, this is how you would write this. Plug this into your calculator, is the same thing as this. So what we're going to do in the next couple examples is look at the possibility when what we're dividing by isn't a perfect factor. In this case, it's a little weird, but we're going to write our answer something like this. Quotient plus remainder divided by divisor. I'll put that up here. Quotient plus remainder divided by divisor. Okay, so let's do another example, but this time, let's do an example that doesn't work. Okay, let's do x cubed minus 3x squared minus 6x plus 8 all over x minus 3. Okay, so we're going to set this up as x minus 3, x cubed minus 3x squared minus 6x plus 8. And now we rinse and repeat. X into x cubed, x squared. X squared times x squared times x is x cubed, x squared times negative 3, negative 3x squared. Okay? And by chance, these both happen to cancel out. That doesn't mean anything's wrong. It just means that's what happened. So we get 0, and we bring down minus 6x. And let's also bring down 8 for when we go to subtract later on. Okay, x into negative 6x. Negative 6x over x is negative 6. Just negative 6, right? Not negative 6x. So that's okay. It just means that we skip over an x term. There's nothing wrong with that. Now, negative 6 times x. Negative 6 times x is negative 6x. Negative 6 times negative 3, positive 18. Okay, these two are the same. Here we get 8 minus 18. That's negative 10. And of course, x minus 3 can't go into negative 10. So here's what our answer actually says. Our answer then says this division is the quotient plus the remainder divided by the divisor. Or if you want to be more particular, minus 10 over x minus 3. This is the same as that 118 plus 4 over 7. Quotient plus remainder divided by the divisor, 830 over 7. So just because something doesn't work out doesn't mean anything's wrong. It just means it means something else. In the case of polynomials, this has use, but in terms of factoring like we were trying to do before, it doesn't quite work out that way. However, this is still of interest to us. Okay, so let's then do another example that maybe also doesn't work, but that's okay. Okay, now let's do something funky like x to the 4th minus 16 over x minus 1. Okay, actually we're going to do x plus 1 instead because why not? Okay, so when we go to set this up, we have x to the 4th, but we're missing an x cubed term, we're missing an x squared term, we're missing an x term, but we finally have our constant term. Okay, so again, if you're missing terms like here, you're missing x cubed, you're missing x squared, you're missing x, make sure you put placeholders in. Okay, so here's what we're going to do next. X into x to the 4th is x cubed times x to the 4th, x cubed times 1, positive x cubed. X to the 4th minus itself, 0 x cubed minus 1x cubed, negative 1 x cubed, and bring down the next term. Okay, x into negative 1 x cubed is negative 1 x squared. And then, again, if you haven't seen it by now, it's just rinse and repeat. Negative x squared times x, negative x cubed, negative x squared times 1, negative x squared. Okay, so negative 1x cubed minus negative 1x cubed goes away. 0 x squared minus negative x squared. Negative is a plus. Just x squared, and we keep going. Alrighty, x into x squared, just x. X into x plus 1, x squared. X times x is x squared. X times 1 is just x. X squared minus x squared goes away. 0 minus positive 1, negative x, and bring down our last term. Okay, x into negative x. Negative x divided by x is negative 1. Negative 1. Negative 1 times x, negative x. Negative 1 times negative 1 is negative 1. Negative x minus itself goes away. Negative 16 minus negative 1. You're $16 in debt and somebody gives you $1. You are now only $15 in debt. Okay, so that means our original question is x cubed minus x squared plus x minus 1 quotient plus the remainder divided by the divisor. And again, you could be a little bit more specific by saying just minus 15 over x plus 1. But I think at this point, if you're watching a video about polynomial long division, I think that part is fairly okay. All right, so this is called long division, and in a lot of ways, this can be very tedious, and it's very easy to make mistakes. So there does exist another type of division when it comes to polynomials that is actually pretty nice. So we're going to do that next. However, I just want to talk about one small thing. Let's say you're trying to divide by something that is more than just like x plus 1 or x minus 5. Let's say you have some polynomial and you're trying to divide it by x squared plus 2x plus 1. So when you go to set this up, x squared plus 2x plus 1 divided by whatever your polynomial is, well, before we had just those two terms, and you said x into whatever that first thing was or whatever that next thing was. In the event that you have x squared, nothing changes. Now it's three terms, now it's going to be a little more work. However, you're still just doing this first term into whatever's next. So let's say we start with an x to the 5th here. Well, then you would have, so whatever, plus, I don't know, 2x to the 4th minus 6x cubed and so on. Okay, x squared into x to the 5th. X to the 5th over x squared is x cubed. Okay? And now the only added difference is when you are multiplying x cubed, is that you have to multiply it by all three. X cubed times x squared, x to the 5th, x cubed times 2x, 2x to the 4th, that is completely by chance, x cubed plus 1, plus x cubed, and now x to the 5th minus itself, 2x to the 4th minus itself, negative 6x cubed minus 1x cubed, negative 7x cubed, and whatever, you bring the next thing down, and you would continuously use x squared. So, all I'm trying to show is that in the event you're dividing by something that is higher than just x, that's fine. This x squared or x cubed or whatever it is will just be your new leading term to divide by. Okay. Also, just like we put placeholders in for the numerators, right? X to the 4th minus 16, we had to do x to the 4th plus 0x cubed plus 0x squared plus 0x minus 16. In the event you're dividing by something like x squared minus 5, well, you have the x squared term, but you're missing an x term in your divisor, so you still put a placeholder just there. So the examples work very similarly when they're just x, compared to x squared, but the same rules of take this leading term, put it into each and every thing, putting placeholders, all those rules are still the same. Okay, so since we have now talked about that, let's move to this other type of division. It is, I will say, not a very mathy way of doing long division, and if I'm being honest, I didn't really get it the first time that I learned it a long, long time ago, but as I've been teaching, it makes a lot more sense. However, not very mathematical, not very algebraic, but if you're looking for a very quick way to do long division, it's really, really nice. So this is called synthetic division, and synthetic division is only for when you're doing division with linear factors. So for example, we've done dividing by x plus 1, x minus 5, x minus 3. You can do synthetic division on those factors. But these last two examples that we just did with an x squared, synthetic division can't work. Synthetic division is only for dividing by linear factors. Okay, so let's go back to this example. X cubed plus 2x squared minus 5x minus 6 over x plus 1. I don't remember what our answer is, but it's okay. We'll match it up with whatever we get. Synthetic division works like this. We're going to set up this little bar here. I don't even know what to call it. So what we're going to do is have a row of numbers up here, and we're going to continuously do calculations below them. Okay, let's start with this. The numbers that go on the inside of our bar will be the coefficients to each of these x's. So x cubed, coefficient is 1. 2x squared, coefficient is 2. Negative 5x, coefficient is negative 5. Negative 6, it is just itself. Okay, that's pretty straightforward, I think. Okay? And then what we're going to put out here is the 0 to our linear factor. So we're not going to put x plus 1 here. We're going to put -1 out here. Okay, that is really, really important here. This is not the number itself. It's the 0 associated with this number. At some point, you've probably talked about zeros already in your classes when you talked about polynomials, and that's what we're talking about when it comes to zeros. It is not x plus 1. It is the 0 associated with x plus 1, in this case, -1. Okay, so how synthetic division works is like this. First step, bring down the first number. Okay, not super scary. What we're going to do is continuously work up, down, up, down, up, down. Okay, to get to here, we are going to take our 0 and multiply it by this number. -1 times 1 is -1. Okay, so it's multiplication to get back up. But then when we go down, so now 2 and -1, when we go down, we add. So diagonals are multiplication, but the columns are addition. 2 plus -1 is +1. And now -1 times 1 is -1. Again, -1 times 1, -1. Okay, -5 plus -1, -5 plus -1. Okay, $5 in debt and you spend another $1, you are now $6 in debt. -1 times -6 is +6. -6 plus 6 is 0. So multiplication, 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 addition, addition, addition. So here's what we get. We now have a row of numbers and we have no idea what they mean. So what this says is that if this was x cubed and we divided all of these terms by a single x, x cubed divided by x would become x squared. X squared divided by x would become x. -5x divided by x would be a constant. And that would leave this last number to be our remainder. And we remember from when we did this example earlier, this had a remainder of 0. So what we get is that our answer is x squared, 1x squared, plus 1x minus 6, and you would put the remainder 0, but we don't need to, right? 0 divided by anything, just 0. So, and now we are back to where we were before. You can multiply x plus 1 on both sides. You can factor as you go. All the steps still the same from there. However, this version, once you get very comfortable doing it, can be very, very fast. So that's really nice because you can do these problems fast. Like, what if you wanted to do division by a bunch of things? What if you don't know what divisor is going to work and you have to check a bunch of divisors? Well, that would be very helpful to us as well. Okay, let's do another one. Okay, let's do x to the 4th minus 26x squared plus 25 divided by x minus 5 again. Okay, so to set this up, this will be the coefficients to all of our x's. 1x to the 4th, we don't have an x cubed, 0x cubed, negative 26x squared plus 0x minus 25. Again, x to the 4th, x cubed, x squared, x, and our constant. Now, the number that's going to come out here isn't -5, it is the 0 associated with -5. So the number that goes out there is +5. Okay, so again, down is addition, diagonal is multiplication. First number comes down. 5 times 1 is 5. 0 plus 5 is 5, right? Multiply on diagonals, but add in the columns. Okay, 5 times 5 is 25. $26 in debt. Somebody gives you 25. You are now just a single dollar in debt. 5 times -1, -5. 0 plus -5 is -5. 5 times -5. Oh, did I make a mistake somewhere? Oh, okay, we got to backtrack a little bit. This coefficient was positive 25 to begin with. Okay, doesn't change a whole lot, but still really important. 5 times -5 is -25, but now 25 minus 25 is 0. So if this was x to the 4th, this is x cubed, x squared, x, constant, and remainder. So our answer is 1x cubed plus 5x squared minus x minus 5 plus a 0 remainder. So again, even though we're doing synthetic division, the step of putting placeholders still there. Okay, well, let's see what this looks like when it doesn't work out. We got 2 more examples and then one more quick explanation, and then we'll call it a day. Okay, we had this one before. We said this one didn't work out, so let's do it again. Okay, add going down, multiply on the diagonal. Up here comes the coefficients. 1x cubed, -3x squared, -6x, and 8, the constant. Now the number that comes out here is the 0 associated with our divisor, which in this case is 3. Bring down the first number. 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. -6 plus 0 is -6. 3 times -6, -18. 8 plus -18, -10. This was x cubed. This has to be x squared, x, constant, and our remainder. Okay, so our answer is x squared plus 0x minus 6 minus 10 over x minus 3. Okay, not so bad. What's one good thing too is that if you're doing what I mentioned before, that you're checking a whole bunch of factors to see what works, you only need to get up to this point. Notice that in the last 2 where it worked, the remainder was 0. So if you get to the point where this is 0, you found a factor of that polynomial. That's really nice. But in the event you get anything else besides 0, then not a factor. And it's a little bit quicker to get to that than doing long division. That part, I will admit. Okay, okay, we don't need to do another full example, but I do want to show you one more thing. Let's say we want to do 2x cubed plus 4x squared plus 8x plus 16 divided by 2x plus 1. Okay, I have no idea what the number is or what the answer is. I did this completely out of the blue. Alrighty, so numbers that go in here are the coefficients. 2, 4, 8, 16. And what we're going to put out here is, again, not this 1, it is the number. It's the 0 associated with this divisor. So that 0 that is associated with it is -1/2. We're going to change this a little bit. Okay, maybe this fixes it. Okay, this is why we don't do things on the fly. Okay, so we changed it a little bit, but now let's go through all the steps. Bring down the 2. -1/2 times 2 is -1. 3 minus 1 is 2. -1/2 times 2 is -1. 13 minus 1 is 12. -1/2 times 12 is 6. Oh, -6. Oh, and this actually works. I had no idea this was going to happen. Negative 1/2 times 12 is negative 6. 6 minus 6 is 0. Okay, so that means our answer is, this was x cubed. This must be x squared. 2x squared plus 2x plus 12. I legitimately had no idea that was going to work out. So I'm going to change the numbers so we didn't get some like super ugly fractions. But yeah, that wasn't supposed to happen. But now you see that in the event your divisor is linear, but not necessarily x plus something or x minus something, you have to do something like that. Okay, so with that said, that is polynomial long division. And I know this was kind of long. You see me in the flesh for the first time. This is weird. But yeah, that's that. So next up is 3.4 and 5. We're going to combine that into one section. So I will see you there. Bye. Hi everyone. Thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leswowska-Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.